All right, today we're jumping into an absolutely epic story. Not about battles or kingdoms, but about a revolution inside the human mind. It's the story of how we, as a species, learned to think like scientists, and how that journey gave birth to physics itself. You know, it all kicks off with a question we've all probably asked ourselves. You look up at the night sky, you see all those stars, and you wonder. But how do we get from just wondering to actually figuring out the fundamental laws that run the entire universe? Well, the answer isn't some single flash of genius. It wasn't one person having one big idea. Nope, it was a journey, a real evolution of thought that happened in 5 huge revolutionary leaps, and we're going to walk through every single one. Okay, so for our first leap, we have to go way, way back. I'm talking to a time when looking up at the stars wasn't about some grand scientific theory, it was about survival. Plain and simple. I mean, think about this for a second. For tens of thousands of years, our ancestors were incredible observers. We're talking 30,000 years ago, people are carving the moon's phases into bone. And this wasn't just for decoration, right? This was the world's first spreadsheet, the first piece of data collection. And over thousands of years, that knowledge got more and more sophisticated, leading to calendars for farming and eventually letting people navigate across huge open oceans. So all this knowledge was super practical, right? It told you when to plant your crops, when to harvest, and how to find your way home. And whenever something is that important for survival, well, it becomes a source of power. You can bet that priests and rulers guarded this knowledge like a state secret, using it to keep everyone else in line. But for all that practical knowledge, there was a big catch. Anytime something weird or unexpected happened, like an earthquake or a solar eclipse, the explanation was always the same. The gods must be angry. That was the default setting for humanity for millennia, until one guy, around the 6th century BC, decided to flip the script. And this slide, right here, it nails the change. Before, an earthquake was Poseidon throwing a tantrum, but then this guy Thales of Miletus comes along and asks a totally different kind of question. Okay, but what's the physical reason for this? He suggested, maybe we can explain the world using logic and natural stuff, not just by blaming angry gods. I mean, that was a huge, huge deal. And the best part is, Thales wasn't just some armchair philosopher. When people made fun of him for being poor, he was like, oh yeah, watch this. He used his new way of thinking, his understanding of patterns, to predict a massive olive harvest. He then went out, cornered the market on all the olive presses, and made an absolute fortune. And he didn't even do it for the money. He did it just to prove a point. This new thing, this reason, it wasn't useless, it was power. Okay, so Thales gives us the tool of reason. That's leap 1. But to really start describing the universe in detail, we needed a language. And that's where our next big thinker, Pythagoras, comes in. He thought he'd found the secret code. For Pythagoras and his crew, the universe wasn't just a messy, random place. No, they believed that underneath all the chaos, there was this hidden, beautiful, mathematical harmony. Their big idea, their whole philosophy could be boiled down to this. All things are numbers. And what was their proof? Their exhibit A? The Pythagorean theorem, of course. A squared plus B squared equals C squared. Here was this perfect, unchanging truth about the real world, and you could write it down with just numbers and symbols. It was beautiful. It seemed to prove everything they believed. Until it didn't. Because that beautiful, clean little system was about to crash headfirst into a massive problem. And the crazy part is, the problem came from their very own theorem. So let's ask the same question they did. What happens when you take the simplest right triangle you can imagine, where the 2 short sides are just 1? Well, the answer for that third side is the square root of 2. And for the Pythagoreans, this was an absolute disaster, a nightmare. Why? Because the square root of 2 is irrational. You can't write it as a nice, clean fraction. The decimal just goes on and on and on forever, never repeating. It was a number that clearly existed, you could draw the triangle, but it completely broke all the neat and tidy rules of their math. This wasn't just a math problem, it was a philosophical crisis. This discovery was so shocking to their perfect worldview that they literally treated it like a dangerous secret. It was forbidden knowledge. It proved that reality was way deeper, way more complex, and, frankly, way weirder than they had ever imagined. Okay, so where are we? We've got reason from Thales. We've got the language of math from Pythagoras. But that whole irrational number mess showed that even a powerful system can have cracks in its foundation. So the next big question became, how do you build a system of knowledge that's basically indestructible? How do you make it bulletproof? This brings us to leap number 4. The answer came from a genius in Alexandria named Euclid, and his idea was the blueprint for pretty much all of modern science and math. He said, let's start with axioms. What's an axiom? It's just a fundamental, super obvious truth that nobody can really argue with. Think of it as the rules of the game. Like, you can draw a straight line between any 2 points. Duh, right? But that's the point. You start with things that are undeniably true. And here's where the magic happens. Starting with just a handful of those simple, well, obviously rules, Euclid built an entire system. In his book, Elements, he logically proved hundreds and hundreds of complex ideas about geometry. It's like building this massive, unshakable skyscraper on a foundation of solid bedrock. If you agree with the simple rules at the bottom, you have to agree with everything he builds on top of it. That is rigor. That's the axiomatic method. All right, we're at our final leap. And this is where everything we've talked about comes together. It all culminates in the mind of one person, an absolute giant of history, who really becomes the prototype for the modern scientist. This was Archimedes of Syracuse. And what he did was brilliant. He took the rational thinking from Thales. He took the language of math from Pythagoras. He took the logical structure from Euclid. And then he added his own secret sauce, the final game-changing ingredient, actually testing stuff in the real world. Physical experimentation. And you know the story that perfectly captures this, right? His famous eureka moment. The king asks him to figure out if his crown is pure gold, but he can't damage it. So Archimedes is thinking, and then he gets in his bathtub, sees the water level rise, and it hits him. He can measure the crown's volume by how much water it displaces. He had just used a physical principle to solve a real-world problem. That right there, that's the birth of physics. It's theory and practice coming together. So there you have it, from just looking at the stars for survival to the powerful, complete toolkit of Archimedes. These 5 leaps gave us the foundations of physics: observation, reason, math, logic, and experimentation. And those are the same tools we use today. Which leaves us with one big question, doesn't it? What incredible secrets about our universe are we, right now, still waiting to uncover?